In the introduction to organic compounds, we have seen that we have different organic compounds. Now we are going to see every one of them one at a time. Halides are those compounds that are when we have a halogen that replaces an atom of hydrogen in an alkane. The functional group is the halide. For example, here we have uh, 2-fluoro, because fluorous is in carbon 2, propane, because we have 3 carbons in the main compound. As the carbons are joined by single bonds, it is an alkane, and the ending is -ane. But also we have alcohol. The functional group of alcohol is the OH, that we call hydroxyl group. The ending of the alcohol's name is -ol, and the beginning depends on the number of atoms of carbon, as we have seen before, with the corresponding prefixes. For example, here we have 2 atoms of carbon. Then we are in front of the alkane. The corresponding alkane without 2 atoms of carbon is ethane. Then we change the ane ending by -ol, and then we have ethanol. In this case, we have methanol if we have only 1 atom of carbon, ethanol if we have 2 atoms of carbon, propanol for 3, butanol for 4, pentanol for 5. Example: this compound contains 4 atoms of carbon. The alkane name is butane. Then we remove the E and we add -ol, butanol. As the alcohol group is in group 1, in carbon 1, we say 1-butanol. If it were in carbon 2, for example, in this case, is 2-propanol. The organic acids have a functional group COOH. The carbon is bonded by a double bond to an oxygen and by a single bond to the hydroxyl group. But this group together is known as carboxyl group, and is a characteristic group of the organic acids, or also known as carboxylic acids. For example, here we have propanoic acid. Propane were the corresponding alkane. Then we drop the E and we add oic acid to name the corresponding organic acid. Here we have an example. In this case, we have the methanoic acid. And here we have the functional group for aldehyde. The acid contains an OH, but the aldehyde contains only an H. And of course, the double bond with the oxygen. Then this is the characteristic functional group for aldehydes. What you have to do is to drop the E to the end of the alkane and add al, because it's an aldehyde. In this case, it's propane, propanal. Propanal is the corresponding name for the aldehyde. At this, here you have methanol, and here you have ethanol, two aldehydes. Alcohol can be oxidized to aldehydes if they are primary alcohols. For example, here we have ethanol, two atoms of carbon, the double bond to the oxygen, and the hydrogen in the other hand. When the double bond of the carbon with the oxygen is between two atoms of carbon, then we are not in front of an aldehyde, we are in front of a ketone. Here you have an example, 2-pentanone. Pentanone because of the 5 atoms of carbon, and 2 because the carbonyl group is in carbon 2. Here you have the acetone that is sold at the pharmacies. The corresponding name as the IUPAC is propanone. Prop because of the 3 atom of carbon, and on because it's a ketone. The esters are made because the hydrogen in the alcohols are joined together. Sorry, the ethers are made of the union of two alcohols. The hydroxyl group of one alcohol and the hydrogen of the other make water, and then they join together. Ethers are the only compounds that contain an oxygen between two atoms of carbon. The way you have to name this compound is naming the alkyl group of one of the original alcohol, and the second one alkyl group of the second alcohol. For example, we have diethyl because we have two ethyl groups, ether, and the oxygen is the bridge between the two alkyl groups. Oxygen it can join, for example, in this case, the two methyl groups, and then we have dimethyl ether. Here we have methyl, ethyl, ether, ethyl, propyl, ether. Esters are organic compounds with general formula as you can see here. What you have in this case, okay, you have a double bond with one oxygen and a single bond with the other oxygen. We can find esters in the bananas, in the pineapples, in all the fruits. How to name esters? First, we name the alkyl group, and then we change the oic ending for the acid into 8. For example, in this case is ethyl because of the ethyl group, and then this is propanoic acid. We change the oic by 8, propanoate. Here we have the ethyl 1, 2, 3, 4, 5 pentanoate. Amines contains a functional group that corresponds to the ammonia. if you change 100 of ammonia NH3 by an ethyl group, an alkyl group, sorry, in this case methyl, you say methanamide. If in this case, when you change the OH of the acid by a nitrogen group, then we are in front of amides, and the name of them are propanamide, butanamide, and so on. Well, we have different organic reactions that we are not going to study in this semester. Well, that's the introduction of the different organic compounds.